Alright, so today we're talking about the number system. Okay? We're talking about real numbers. We're not going to get into imaginary numbers today. So today you need to know everything that's under a real number. Okay, Morgan? So here under real number I have a rational number, irrational number, integer, and whole number. That's what you're responsible for today. Okay? So let's start at the bottom. What is a whole number? Let's tell the definition of a whole number.
Positive number.
This is a positive number that's not a decimal or a fraction. Okay? So let's write a whole number as a positive number that is not a decimal or a fraction. So we know a whole number is a positive number that is not a decimal or a fraction. Somebody give me some examples of whole numbers.
2,
2,
10,
10,
5,
4, and 5. Okay, those are good ones. 2, 10, 4, and 5 are all what?
whole number.
Okay? Now, what's something that's not a whole number? 2.5,
4.4,
4.4, 3.6,
.04,
negative 10.
2.4,
Negative 10 is not a whole number because it's
negative.
negative. Because it's negative. Negative 10 is negative. Okay? Now, the next thing we're going to talk about is an integer. Alright, so an integer is our next classification. And it's a whole number that is negative or positive. So an example of that would be negative 10. Another example would be positive 10.
Negative 5,
Okay, negative 5 or 5. All those are examples of integers. Now, our next classification, the thing that we need to tell the difference between is going to be whether something is a rational number or an irrational number. Okay? Something that's a rational number can be described in the format A over B when B does not equal 0. Okay? In the format A over B where B does not equal 0. In other words, the denominator here cannot be 0. Okay? It's in the format A over B where B does not equal 0. And A and B are what? Integers. Okay? So, the definition of a rational number is a number expressed in the format A over B where B isn't 0 and A and B are integers. Now, I'm going to give you an example of a rational number. Okay? An example of a rational number. 2 over 3. Now, does this follow our rules? Is A an integer?
Yes, sir.
Yes. Is B an integer?
Yes, sir.
So, these are true. Does B equal 0? No. So, this is an integer. Okay? This is a rational number, I mean. Now, on the flip side, 2 divided by 0. Well, 2 is an integer and 0 is an integer, isn't it? But B equals 0, doesn't it? So can 2 over 0 be a rational number? No, since it's not rational, what is it?
Irrational.
Irrational. Okay? Now, you cannot divide by 0. If I take something, okay, let's say I take this card right here. Alright? Here it is. And I want to divide it by 2. I just divided by 2, didn't I? Now it's 2 pieces. Now if I want to take this card, now I have 2 cards, and I want to divide it by 3. 1, 2, and 3. Right? When I take something and divide it, I wind up with something. Okay? But, can I take this card and rip it in any way to where it doesn't exist anymore?
No.
So I can divide it into 2 pieces. I can divide it into 3 pieces. I can divide it into 4 pieces. But can I ever divide it into no pieces?
No.
No. That's why you can't divide by 0. You can't take something and make it into nothing. Okay? I can't, no matter how small my pieces are, just like when you rip up your homework, there's still something there, isn't there? Whether it's a lot or a little, it's there, isn't it? Do you understand? So you can't divide by 0 for that reason. When you take something, you can't make it into nothing. Now, the definition of an irrational number is the number A over B, where B does equal 0. Okay? Or it's a decimal that does not terminate or repeat. Okay? It's a decimal that does not terminate or repeat.
Don't terminate means the same thing as repeat.
Now, how many of you have seen the movie The Terminator? What does he do to people on The Terminator?
Terminate them.
He gets rid of them, right? Now, to terminate them means to get rid of them, to kill them. Okay? So if I have a decimal, let's say I have a decimal 0.226. Does it stop? Yeah, 0.226. It stopped at 6. It's no more. It doesn't,
Oh, I got
it doesn't keep going, does it? So since it terminates, it is a rational number. Okay? But now let's say it went on forever. 0.164897433. Then it's a irrational number. Okay? Now, there's an exception. Let's say it does like 0.333 and it does the same thing forever. Then it is rational. So the only way it's irrational is it goes on forever and doesn't have any kind of pattern.
So if we got 4.
Now, some examples of irrational numbers would be something like 2 divided by 0. That's irrational because it's being divided by 0. Another one would be 0.42679. And then when they put dot, dot, dot like that, what's that mean?
So wrong.
It keeps going on. Now, does this have any kind of pattern?
No.
No, so this is
Irrational.
irrational. So here's 2 good examples of irrational numbers. Now, y'all tell me, is this number 0.1212312434 going on forever? Is that, what is that, rational or irrational?
Irrational.
Irrational because it shows no pattern. It is irrational. Now, it's irrational, but it's also real. So you have to say that on your homework. It's real and irrational. Okay? Now look at the number 12. What is it?
A whole number.
It's a whole number, which means it's a
Integer.
and
Rational.
and real. So you got to write all 4 of those. Now, can a number be rational and irrational?
Yes.
No. That's what we got the line.
Oh.
Can you be a man and a woman at the same time?
No.
Okay. Hopefully not. Okay. Look here. 0.008. Is this a terminating or non-terminating decimal?
Non-terminating.
It's non. So, hold on.
I don't know.
So it goes on forever. I don't see the rest. Where's it at?
I don't know.
Is my eyes bad?
No,
No, it stops right there, doesn't it? So it's terminating, which means it's
So real rational number.
rational. It's a real rational number. Good job, McGavin. Okay, look right here. Square root of 13. Does this give me an even number?
It's a
No.
whole number.
No, it's not a whole number. It's square root of 13. Does it give me an even number? No, so it is irrational and
a real number.
And a real number. What about 16.7? Is this a terminating or non-terminating decimal? Terminating. It stops. Okay? Since it's terminating, it is what?
A rational.
A rational number and a real number. Is it an integer?
No.
No, because it has a decimal. What about negative square root of 7? What's the square root of 7?
-7.
No, what is the square root of 7? We don't know. It's a decimal, right?
Oh.
Since it's a decimal, it's irrational because it'll continue to go forever.
A real number.
And a real number. Okay. So today you learned how to classify rational and irrational numbers.